All right, so we're gonna take the derivative by using logarithmic differentiation. So what we're gonna do first is take the natural log of each side. So then we'll have the natural log of y be equal to the natural log of all this. And I'm gonna rewrite the square root as a 1/2 power because that's essentially the same thing. So x squared plus 1 to the 1/2 power. Moving on, keeping the left the same, the natural log of y equal to, and I'm gonna then use my properties of logarithms because we're dividing here. So that means you can subtract, and we'll get the natural log of x minus 2 to the 2nd power minus the natural log of x squared plus 1 to the 1/2 power. Keeping the left the same as the natural log of y. And then we just do one more property where we move the exponent as a coefficient. So we have 2 times the natural log of x minus 2 minus, we move the 1/2 power as a coefficient. So minus 1/2 times the natural log of x squared plus 1. Now we can take the derivative of each side. So we're going to use implicit differentiation because we have the derivative of y essentially. So we're going to take the derivative of this logarithm, which is going to be 1 over y times the derivative of y, which we'll leave it as y prime. Then we take the derivative of this. So that, remember, the 2 is just a coefficient, so it stays as 2 times the derivative of the natural log of x minus 2. So the derivative of the inside here, x minus 2 is just 1. So we have 1 over this, 1 over x minus 2. All of that is being multiplied by 2. And then we're going to have this minus 1/2 times the derivative of all this. Again, we take the derivative of the inside. So the derivative of x squared plus 1 is 2x. So we're going to have 2x on top all over this group. So all over x squared plus 1. And all of that is multiplied by that 1/2 here. And so these 2's cancel. And then so essentially we have y prime over y be equal to 2 over x minus 2. Oh, minus x over x squared plus 1. The rest of this is really just algebra. Not easy algebra, but it's really just algebra now. So let's find a common denominator. That's why I left a space here. So when the common denominator is going to be x minus 2 times x squared plus 1. So this group we're going to multiply by x squared plus 1 over x squared plus 1. Like that. A little messy, but it'll do. And then this group, we're going to multiply by x minus 2 over x minus 2. And that way we have a common denominator of x minus 2 times x squared plus 1, all here, all in the bottom. So we'll get y prime over y be equal to, so on top we'll have 2x squared plus 2 minus x squared plus 2, looks like. because then we have an x and an x. Minus x, oh, minus x squared and then a minus 2x in here. All over x minus 2 times x squared plus 1. Next, we're gonna simplify the top. Let's multiply both sides by the y in the denominator there. So we'll have y prime be equal to y over 1. Because that's, again, we're sending this to the right side because we only want y prime by itself on the left. The top will become an x squared plus 2, so x squared plus 2x plus 2. All over an x minus 2 times an x squared plus 1. Oh. Move my paper out. There. We're almost there. The thing is, we have to rewrite this y as the original because we need it in terms of x. So let's rewrite it as this with the algebra, and let's rewrite the x squared plus 1. Let's put that as like a power, so it's the 1/2 power. So then what we get is that y prime will be equal to x minus 2 squared over x squared plus 1 to the 1/2 power. All that multiplied by the bottom is going to be x minus 2 times an x squared plus 1. The top will be just that x squared plus 2x plus 2. And then see, we will be able to cancel some stuff down. We're going to be able to bring this down, power this one down, so we just have an x minus 1 there. And these two we combine because these are both the same base, x squared plus 1, x squared plus 1. And so all be over x squared plus 1 to the 3/2 power. Because 1 plus 1/2 is 3/2. And then on top, we just have that x minus, oh, whoops, this is an x minus 2. We'll just have that x minus 2, just to the 1 power though, because we just factored it, times x squared plus 2x plus 2. And there we go, there's our final answer. Yeah, I know it doesn't look finalized, but just get used to like it not always breaking down simply. That's just the way math is going to be from here on out. And with logarithmic differentiation, it can be tedious. So sometimes maybe you just want to avoid it. It just depends. But this is a good example just to see how we can use the properties and all that to differentiate. So I hope that helps. I'll see you guys in the next video. Bye.